Let's start from the beginning. Here we go.
The cycle refers to the sequence of events that occur and repeat with every heartbeat. It can be divided into two major phases, systole and diastole, each of which subdivides into several smaller phases. Systole and diastole, when not specified otherwise, refer to ventricular contraction and relaxation, respectively. Reminders: blood flows from higher to lower pressure. Contraction increases the pressure within a chamber, while relaxation lowers the pressure. AV valves open when atrial pressures are higher than ventricular pressures and close when the pressure gradient is reversed.
So those are very important points if you really want to understand the cardiac cycle, okay? So we talked about this. Does everyone feel pretty comfortable with that, understanding that blood is always going to go from an area of higher pressure to lower pressure? All right, similar to like ion flow kind of thing, but this is pressure related. It's a pressure gradient instead of a concentration gradient. Contractions will always increase the pressure. It's like puffing out your cheeks in your mouth. You blow hard but keep your mouth closed, you're going to build up the air pressure inside your mouth. Same thing with the ventricles and the atria. That will happen, okay? And then the valves will open and close depending on wherever the pressure is greater on one side or the other. Meaning, in our example here, if we're looking here in the atria, if the pressure is greater in the atria than it is in the ventricles, remember the valves are one way only. They're either open or closed, okay? So they can only open into the ventricle, okay? So the pressure is greater in the atria than it is in the ventricle. That'll force the AV valves to be open. Okay? If the pressure is greater in the ventricles than the atria, that'll force the valves closed. Okay? Same thing here when we're talking about the semilunar valves. All right? If the pressure in the if the pressure in the ventricles is greater than the pressure in the arterial circulation or the pulmonary trunk and the aorta here, it'll push the semilunar valves open and blood will flow out. But if the pressure in the aorta, okay, in the pulmonary trunk is greater than the pressure down here in the ventricles, it'll keep it closed. Okay? So keep that in mind. We'll go through that.
Similarly, semilunar valves open when ventricular pressures are higher than aortic pulmonary pressures and close when the reverse is true. The cycle is initiated with a firing of the SA node that stimulates the atria to depolarize. This is represented by the P wave on the ECG.
I know all this stuff, I had to learn all this when I was in med school, so a lot of it's just going to be some lines to some of you. So don't worry about it. We'll work through it in lecture, all right? But we will talk about an ECG, okay? And that it's the electrocardiogram here, the P wave here is atrial depolarization. We'll probably talk about that on Monday. Right, and we can see the SA node is depolarizing. It's washing across the atrial walls here, spreading over to the other atria, and it's virtually simultaneous when they depolarize. What follows depolarization? Contraction. Contraction, contraction. Okay?
Atrial contraction starts shortly after the P wave begins and causes the pressure within the atria to increase, forcing blood into the ventricles. Atrial contraction, however, only accounts for a fraction of ventricular filling because at this point, the ventricles are already almost full due to passive blood flow down the ventricles through the open AV valves. As atrial contraction completes, atrial pressure begins to fall, reversing the pressure gradient across the AV valves, causing them to close. The closing of the AV valves produces the first heart sound, S1.
That's the lub dub, okay? S1. Heart sounds, all right, or at least the normal physiological heart sounds are always closure of valves, okay? So the first one are the AV valves closing. What do you think S2 is going to be? That's the second heart sound. The what? Well, the semilunar valves will close. Yeah, all right. Yeah, so the first heart sound, AV valves closing. The second heart sound will be the semilunar valves closing, okay? These, just to kind of show you up here, this top portion, that's the aortic pressure, right? And that's what we're talking about when we're dealing with the aorta here, right? Atrial pressure, obviously these two guys, the atria, ventricular pressure, obviously here, and then ventricular volume, obviously blood volume, and then our electrical conduction system for the heart here is the ECG. Just in case, just a quick review.
And marks the beginning of systole. At this point, ventricular depolarization, represented by the QRS complex, is halfway through, and the ventricles start to contract, rapidly building up pressures inside the ventricles. For a moment, however, the semilunar valves remain closed, and the ventricles contract within a closed space. This phase is referred to as isovolumetric contraction because no blood is ejected and ventricular volume is unchanged.
See that? All the valves are closed, so blood can't go anywhere. So it's isovolumetric.
Ventricular ejection starts when ventricular pressures exceed the pressures within the aorta and pulmonary artery. The aortic and pulmonic valves open and blood is ejected out of the ventricles. This is the rapid ejection phase. As ventricular repolarization, reflected by the T wave, begins, ventricular pressure starts to fall and the force of ejection is reduced. When ventricular pressures drop below aortic and pulmonary pressures, the semilunar valves close, marking the end of systole and beginning of diastole. Closure of semilunar valves produces the second heart sound, S2. The first part of diastole is, again, isovolumetric, as the ventricles relax with all valves closed. Ventricular pressure drops rapidly, but their volumes remain unchanged. Meanwhile, the atria are being filled with blood and atrial pressures rise slowly. Ventricular filling starts when ventricular pressures drop below atrial pressures, causing the AV valve to open, allowing blood to flow down the ventricles passively. The atria contract to finish the filling phase, and the cycle repeats itself.
Kind of see how that works, how the heart, the passage of blood, it's kind of neat. Again, it's 4-minute, 11-second video. I would recommend watching it after the test, you know, watching it a couple times, break it down and look at it and just and rewind. All right. All right. Oh, now I know why they did that. Wait 1 second. Okay, so let's quickly kind of finish up the heart cycle here. And I just wanted to go over pictures at the end, just to walk you through it one more time. Okay. All right, so we're going to start off here, and there's 3 things that you want to keep in mind the whole time as we're going through, all right, the phases, the heart cycle. All right, first, what's going on with the chambers, the atria and the ventricles. Second, ventricular pressure. Third, what the valves are doing. All right, we're going to walk through that. If you kind of understand what's happening, that'll help you to understand this a little bit better. So I'm actually going to start on the next slide here because I like to start here when everything's kind of relaxed, okay? So atrial relaxation and ventricular filling is where we're going to start. Get rid of that. There we go. Okay, so y'all can see that? Okay, so we just ejected the blood from the ventricles. The pressure has fallen in the ventricles so much, all right, that it's less than the pressure in the atria. So the AV valves are now open. Okay, and this is the part where we call it passive filling. Okay, so as blood is coming in, all right, from the right side of the heart here, the superior vena cava, inferior vena cava, in the coronary sinus, all right, it's going to flow into the right atria and it's going to pour into the right ventricle. Same thing will be happening over here in the left, all right, atria. All right, as blood is returning from the lungs, it'll come into the left atria and pour right into the left ventricle. So this is the passive filling phase. Okay, so the pressure is slowly starting to build up here in the ventricles. Well, nothing's contracting yet. Okay, just the actual pressure from the volume of the water, of the blood. Okay, as it's starting to fill. Okay, so now, and you can see here, chambers. All the chambers are relaxed. Okay, the atrial pressure here, all right, the ventricular pressure is less than the atrial pressure. That's why the valves are open. Pressure is always, remember, keep in mind, where the valves are, you always got to consider what the pressure is in front and behind the valves. If the valves are open, then you have to assume, all right, the pressure is greater behind the valve because it's pushing the valve open. All right, so these AV valves only open into the ventricle, so the pressure in the atria is greater. Okay. Meanwhile, the semilunar valves are closed. Okay. So that tells us that the pressure of the ventricles is less than the arterial trunk pressure. Arterial trunk is the pulmonary trunk in the aorta. Okay, that's what they're referring to. Okay, so the arterial trunk pressure is less, all right, than the atrial trunk pressure. No, the ventricular pressure is less than the arterial trunk pressure. So that's why these valves are closed. Okay. Okay. So blood starts to fill up. We'll go to the previous slide and start the cycle. All right. So now what happens? The SA node starts to depolarize. Okay. And it begins to depolarize and spread across all the cardiac muscles. Now the atria start to contract. Okay. And as it contracts, it gets that last bit of blood out of the atria and pushes it down into, all right, the ventricles here. So we go to the chambers. What's happening in this phase? All right, atria are contracting. The ventricles are still relaxed. So the ventricular pressure is still going to be less than the atrial pressure. How do we know that? The valves are still open. Okay, the pressure has to be greater on one side to push the valves open. Okay, it's a one-way street here. All right. Also, the ventricular pressure is still less, all right, than the arterial pressure because the semilunar valves are still closed. Okay. Now, remember, blood will leave the ventricles and go into the arterial blood system, all right? But if it opens those valves, that means the ventricular pressure is greater than the pressure on the other side of the valve there, all right? So in this situation here, we're looking, all right, the valves, the AV valves are open, the semilunar valves are still closed. Okay, so we finished our contraction there, okay, and we squirted all the blood into the ventricle. So now the atrial muscles, they start to relax a little bit. So their pressure decreases here, all right? What happens is the AV valve will then close, okay, because the ventricular pressure now is greater than the atrial pressure. So that will cause the AV valves to slam close. There's our S1 heart sound, the love. Okay? So now both sets of valves are closed. So hence we call this the isovolumetric, meaning the blood volume does not change at all because all the passageways or doorways into these chambers are closed. So nothing can happen. Okay? So what we start to see here is the atria are relaxed. Now the ventricles start to contract. We need to start building up our pressure inside the ventricles because our goal is to overcome the arterial pressure so we can open these valves up, so we can push the blood in these ventricles out into the systemic circulation and into the pulmonary circulation. Okay? So the ventricular pressure is greater than the atrial pressure, hence that's why these valves close, but it's still less than the arterial trunk pressure. So that's why these valves are still closed. Okay? Which moves us here to what is called on the video rapid ejection or ventricular ejection. So we look at the chambers, the atria are still relaxed, all right? The ventricles continue to contract. By this point, we've built up enough pressure that we overcome, all right, the pressure in the arterial system. So we now are able to push the blood from the ventricles out, all right, into the pulmonary trunk and into the aorta, all right? So the ventricular pressure is still greater than the atrial pressure because the AV valves are still closed, okay? And also now we see the ventricular pressure is greater than the arterial trunk pressure because it's pushed open those semilunar valves and we push that blood out into circulation. Okay, so the valves here, all right, AV valves are still closed, the semilunar valves open up. Okay, which brings us here to the isovolumetric relaxation. Okay, so we contract, you squirt the blood out of the heart. Okay, does anyone remember what that blood volume that we just squirted out of the heart, what's that called? Is it up there? Yeah, it's kind of up there. Stroke volume. Stroke volume is the amount of blood in milliliters, the volume of blood that leaves the heart, all right, when it contracts, okay? So in the isovolumetric relaxation, okay, the atria are still relaxed, but they're filling, okay? They've been filling this whole time, right? But the ventricles now are also relaxing. So as the ventricular pressure, all right, starts to fall, all right, the pressure here becomes less, all right, than the arterial trunk pressure. The semilunar valves close. That's our S2 heart sound. Okay, that's the dub. Okay, but at the same time, the ventricular pressure is still greater than the atrial pressure because the AV valves are still closed. We haven't opened those up yet. So again, isovolumetric, we are not changing the volume of the blood, all right, in the ventricles. Okay, it does not change. We have a little bit of blood left over. We can't squeeze it all out every time, all right? And the volume of blood that remains behind is the end systolic volume, okay? All right, and then finally we go back to this beginning part that I showed you, atrial relaxation and ventricular filling. Eventually then all the pressure in the ventricles have fallen so much, all right, that the pressure in the ventricle is less than the atrial pressure, and then the AV valves open up, the blood that was building up in the atria start to pour into the ventricles, okay, and that's the passive filling, all right? Semilunar valves are still closed, okay, because the pressure in the ventricles is less than the pressure in the atrial circulation here, okay? But the AV valve is open because our pressure is greater on this side. We start to fill up for the passive filling, and then we repeat the cycle, okay? Watch the video, go over the notes. I know it's still a lot, but if you really understand the pressure gradient, where pressure, I think pressure is probably, if you understand that pretty well, then you'll have a pretty good understanding of what the heart's going to be doing, where the blood's going to go. And if it makes sense, when you start to contract, the muscles are contracting, you're going to increase the pressure. When they relax, pressure is going to decrease. All right? If a valve is open, okay, that means that the pressure on the other side of the valve, all right, is going to be greater than the area of where the valve opened into. That's how I remembered it. Okay? It's just one of those things.
Need a heart to watch.
Yeah, watch the heart. Go over this. I start with these. You know, I would use these first to kind of give you a breakdown, and then you can go into a little bit more of a detailed note. Okay. I'm going to stop recording here.